Now, let's take a look at what does the end behavior of a polynomial function is all about. Now, before that, let's go back to write out the polynomial function again. So that's f(x) equals to a(n) x to the power of n plus a(n) minus 1 to the x to the power of n minus 1 and dot 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 plus a1 to the x and a0. All right. Now, recall that even when I was doing polynomials, we do understand that some terminologies that an is called leading coefficient, and the highest degree among all the variables of x, that is called the degree of the polynomial, right? So now that time it says degree of the polynomial. Now it's a degree of the polynomial functions or function, the specific function. Now another thing is just as addition, when we write out the polynomial functions, we usually go by the so-called the descending order of the x degree. All right. So now let's first of all take a look at the end behavior of polynomial functions. Basically talking about the graph. The general understanding about a graph of the polynomial function. Well, the last section, the part 1 for 3.1, we talked about that the graph of polynomial functions, there's all the smooth curve. There's no breaks, there's no very sharp turn points, so everything is basically just kind of not this kind of sharp turn, but it just kind of at this point it will be smoothly curved somewhere else. All right. Now, what does the end behavior mean? It means the beginning of the graph and to the end of the graph. And they have a pattern. A beautiful, beautiful pattern for us to take a look. Now, first of all, I want you to bring to your attention is this. Polynomial function. I'll take a look at this. What is a domain? Let's take a look. Domain. The domain of this function is, as we all know, x. Now, x is all real numbers, right? So that is our domain. So in this case, if you think about the graph will be starting from somewhere, either down here, right? Goes something, it will be always ended up over here. But if you started from the second quadrant, you kind of like, of course you could just be over here. You could be just over here. You don't have to cross the x-axis, but you can well think that you will cross the x-axis and then end up at the fourth quadrant. So from third, you could end up at the first, or from the third, you could, of course, you can end up over here, right? But you're going from, so what I'm trying to get at is that it will have no graph that you would only have a curve here. Or even, you can have a curve just over here. That's not a problem. You can have a curve over here. That's not a problem. But you won't have any curve that will be from 1 and 4, because this, first of all, this is not even a function, or from, well, you could have this one. You could have this one here, right? But when you do this one, you understand this is eventually still will go, because this thing forever go down. So it still will be going into the fourth quadrant. Only this one, this line. But this is not even a function. This vertical line is not a function because the m is infinity. M equals to 1 over 0. So this is undefined, right? So this is undefined. So basically, we needed to know how this graph starts and how it ends. They would really help us to right away imagine the graph. So now let's take a look at this. So we can start, oh, what's here? Okay. We can start with the very general polynomial functions. Now take a look at here. This is fx equals to x, fx equal to negative x. So this is a positive slope, this is negative slope. Now this is another very typical, this is a quadratic, x squared, negative x squared. Now we'll go further, higher degree. This is x to the third, it goes there. This is negative, it comes down like that. Now the 4, look at that, it's still a parabola. And the negative 4 facing down. It's only, see, it's only narrower. We talk about this is called the vertical expansion, or it could be horizontal compression. Now similarly here, this is a vertical expansion. This is already the power of 5 compared to the power of 3. And then this negative, then go from this to this. And this is the 6, right? So this is our basic graph. Now from here, let's imagine if something that is not just as simple as your original basic graph, it is something like, you know, a to the power of, let's take a look at this, a to the power of 4. And then there's some other things tagging along until it's to the constant. So take a look at here. There's still, this is going up, this is going up, this is also going up. In between these turn, we're going to get into the turning point next part. How many turns do we have? We do not concern yet. The end behavior, it is going up here, it's going up here, and this is all going up here, it's going up here. However, if this is negative, take a look at if it's negative. Wow, it's just like the quadratic. It's going down here, going down here. Again, in between, we are not concerned about yet. But look at the pattern. Going down, going down, going down, going down. All right. And then, however, so this is a 2, this is a 4. So this means when n is an even number, is an even number. You see that? Now take a look at the pattern here. Now this is a 3. And this is a 5. 3 or 5. Cannot even see it, just say 3. Okay? So yeah, it's a 3 because its shape is now changed. So now for 3, then this is starting from the third quadrant and then go up. And then it ended up at the first quadrant. See that? It says the uptrend. So it's from down to up. Now same thing, down to up. Now in between, again, in between how it behaves, we're not worried about it. So this is go up, but however, if it's a negative, then this is going from the second quadrant down to the fourth, and this is going down. So again, this is down, down. This is down and down. So the end behavior now, what we can tell is basically for any fx equals to a n x this plus that plus all the way a1 and x plus a0. So the most important thing is this leading coefficient and the power. All right, so now we also divide them into when n is an even power, it's an even number. So then in this case, this is the end behavior. There will be always going up. This is going up. Don't worry about what I draw in between. So no matter what this is in between, don't worry about it. So another way to draw it, it is just the end behavior like that. Sorry, my drawing is so bad. I still have really hard time to use this drawing tablet. So this is the end behavior. But this also means an is larger than 0. So an is a positive number. So that goes like that. But if an is a negative number, and we all know your end behavior will be down and down, down and down. All right, you can see, well, my graph is down here, but however, I was said before, this will keep going, so then of course it will cross this two region. Okay, so then that is when n is an even number. Now when our n is an odd number, then when an is larger than 0, then we ended up of the behavior of this graph will be starting from here. We'll be starting from here and then wiggle, 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 wiggle in between and then ended up there. But if the an, the leading coefficient, is smaller than 0, then as we already saw the trend, then they will be coming down and then ended somewhere here, going down. All right, so by the way, so this is completely different from this one here. So let's use another color. So this is my set of the end behavior. Now this is my set of the end behavior, and similarly this is my set of the end behavior, and then this is my set of the end behavior.